Here, we are arguing about carbon content and types of ferrous metals. The amount of carbon content in ferrous metals determines their hardness, softness, and other properties. You should be noted that materials may require not only strength, but also other properties such as machinability and ductility. For example, a material may need to be somewhat soft to be processed. The jobs in machine design are selecting appropriate based on the requirements of the application. The following explanation is for appropriate selection of steel materials. Pure iron is known as a not practical material like other pure metals such as aluminum or copper. They do not have special superior features in other applications. Mild steel, which slightly contains carbon, has a certain degree of strength and softness, so it is used for wires and nails. Hard steel contains more carbon than mild steel and is harder. Hard steel is used for structural parts and machining tools. Cast iron has higher carbon content and lower melting points. It is good material for casting. Cast iron is more brittle than mild or hard steel. Cast iron is used for parts that require weight, such as vibration damping tables and counterweights. We are arguing about a bit more detail of four types of ferrous metals: pure iron, mild steel, hard steel, and cast iron. Pure iron does not contain carbon and is not practical for machine parts. Therefore, other components are usually added to pure iron for realizing practical properties as introduced above. A general property of steel materials is that the higher the carbon content, the stronger the material. The important values of carbon content are 0.02%, 0.3%, 2.1%, and 6.7%. 0.02% is the borderline between pure iron and mild steel. The carbon content below 0.02% is not practical for machine parts, as we discussed earlier. 0.3% is the border between mild and hard steel. 2.1% is the border between hard steel and cast iron. 6.7% is the amount of carbon contained in cementite. Iron that contains more carbon than 6.7% is too brittle and collapses with its own weight. These arguments may be better understood associating the state diagram with the crystalline structures.